Now in the matrix, the part 2, just we're discussing about the diagonal matrix. Now where in the diagonal matrix we have seen that the diagonal elements are there. Suppose 2, 3 and 5, and then here it is 0, 0, 0 and 0. This is a diagonal matrix, and the diagonal elements are 2, 3 and 5, and the non-diagonal elements are 0. So it is 3 by 3 diagonal matrix. Now in this diagonal matrix, if this diagonal position, this number are same, then it become the scalar. So it will become scalar matrix. When if I make it same, suppose if I make every one 0, 2, 0, 0, 0, 2, then this will become a scalar matrix. And in this scalar matrix, if I take this all on 1 only, 1, 0, 0, 0, 1, 0, 0, 0, 1, then it is become the unit matrix. Unit matrix or identity matrix I. So it is I3 actually. 3 by 3. So it is I3. So this was in continuation of that. Now we will discuss about the elementary row and column operation to find the inverse of any matrix. The elementary row and column operations. Now what is elementary row or column operation? Now for that we have to understand about the equivalent matrix. Equivalent. Now what is equivalent? Now suppose a matrix is A. A is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is suppose a 3 by 3 square matrix. Now it's equivalent to A. I can write a matrix like this way by just simply interchanging the Ri, Rj, means row I, row j. Suppose R1, R2, interchanging this. Row 1 interchange to R2. Row 1 become R2 and this becomes R1, interchanging. So if I write 4, 5, 6 here, this is 1, 2, 3 and 7, 8, 9, then this is equivalent matrix. Similarly, if I write multiply, this is A matrix is equivalent to, here if I write R1, we are changing it, R1 plus 2 into R2. If I write this way, then it will be like this way. 4, 5, 6 at it, 7, 8, 9 as it is. Now 1 is 1, 2, 3. This 1, 2, 3 become 1 plus 2 into row 2. So that means it will be 1 plus 2 into 4. This will be 5, 2 plus 2 into 5. And this will be 3 plus 2 into 6. That means it will become 4, 5, 6 as it is, 7, 8, 9 as it is. Now it will be 1 plus 2 into 4. 4 to 8 plus 1, 9. It will be 2 5s are 10. 10 plus 2, 12. And it will be 2 6s are 12 plus 3, 15. It is like that. This is equivalent matrix. So this the way we can do the things. Or sometimes we can simply reduce this. Suppose if I write your R3 is changed by, is 1/4 of R3. New R3 is 1/4 of the total R3. Then it will become 1, 2, 3, 4, 5, 6, and then it will become 7 by 3, 8 by 3, and 9 by 3. This is like they are equivalent. The matrices are equivalent. This property if we use, then we can give. Okay. Now to find the A inverse using elementary row operations, we write A is equal to IA. I is the unit matrix, and apply a sequence of row operation on this A is equal to IA till we get I is equal to BA. That means this A will become I and this I will become B. And then B will be the inverse of A. Now we'll take a particular example to see this. Now look at this. Now let us discuss these questions. Using elementary row operations to find the inverse of the two questions I've selected. One is a 2 by 2 matrix and one is a 3 by 3 matrix. As you see, this is from CBSE 2007 and this question is from CBSE 2012. Now first of all, let's solve this one. Now in order to use the elementary row operation, we write what? A is equal to IA. In column operation, we write A is equal to AI. But here in row, you write A is equal to IA. Now A is what? 1, 2, 3, 7. Clear? I is what? 1, 0, 0, 1 because 2 by 2. A as it is. Now first when applying, R2 is replaced by R2 minus 3 into R1. Or I can write this. R2 is replaced by R2 plus minus 3 into R1. Same thing. Now what happens? The row 2 is replaced by row 2, this original row 2 minus 3 into row 1. Now here, so 3 will replace by 3 minus 3 into this one. So 3 into 1, 3 minus 3 into 1. So it is 0. 7 minus 3 into 2. 7 minus 6 to 1. So it is coming 1, 2, 0, 1. Same thing we have to apply here also. So 0 minus 3 into 1 minus 3. 1 minus 3 into 0, 0. So it is 1 only. So it is coming this. Next we are applying R1 is equal to R1 minus 2 into R2. Now then it is coming R1 minus 1 minus 2 into 0. So 1 only. 2 minus 2 into 1, so 0. So 1, 0, 0, 1. Here it is coming 7. Here coming minus 2. Here coming minus 3 and 1. Now this is I. Now it become I. Left hand side we got I is equal to BA. So this is the inverse. So B is the inverse of this. So A inverse we can write 7 minus 2 minus 3, 1. So this is the for usually this come in 2 marks question. But here it is a 3 by 3. So it will have 4 marks. Now we see how we are solving. In order to use the elementary row operation, we write A is equal to IA as we told here also. Now this is a A, this is I, this is A. Now first we are applying R2 is replaced by R1 plus R2 or R2 plus R1 and R3 is replaced by R3 plus 3 into R1. Then we are getting minus 1, 1, 2, 0, 3, 5, 0, 4, 7. Then here get 1, 0, 0, 1, 1, 0 and 3, 0, 1. What you observe here, you always keep in mind. We want to, in the left hand side, we want to get a unit matrix. That means 1, 0, 0, 0, 1, 0, 0, 0, 1. That means our only diagonal part will be remain 1, 1, 1 finally. So the way of doing the tricks is that first try to get these two zeros, these position zeros. In the given matrix, try to get these position zeros. Then you think about these two position zeros. And then finally these two zeros. So once again I am repeating. These are tricks that you will do. You will try out some this way, so that first make this and this part is 0. This should be 1. First try to 1 and this 2 was 0, and then this is 0 and this is 0, and then finally this upper to this 0. Then only you will get 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Now see how we are doing. First of all, these two operations we are getting this one. The next apply R1 is equal to minus 1 into R1. And R2 is equal to 1 by 3 into R2 and R3 is equal to 1 by 4 into R3. So we are getting this one. 1 minus 1 minus 2, 0, 1, 5 by 3, 0, 1, 7 by 4. This you are getting minus 1, 0, 0, 1 by 3, 1 by 3, 0, 3 by 4, 0, 1 by 4 into 1. Again apply R1 is equal to R1 plus R2, then this part is become 0. Because these two are adding, so this part is 0. And then again R3 is equal to R3 minus R2. Now this part is 0. And here, next page you see R3 is 12 into R3, so we are getting this one. Then R1 is R1 plus 1 by 3 into R3, so we are getting 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so I we have got. Now this is B, this is A. Now B is the inverse, so this is the inverse. So A in the I become A inverse A. So this is the inverse. What? 1 minus 1, 1 minus 8, 7 minus 5, 5 minus 4, 3. So you're getting so this way, this is a skillful question. A skill you need to get how this one, and this needs a practice. If you do practice, you will get. Okay.